Alright, hello and welcome. So one thing that you can build from a probability distribution is an expected value. So kind of knowing the distribution of your variables, what values you can take, and knowing what's the probability of each, it will give you an idea of what's expected in the future, for example. So kind of based on this data, what's the expected value of how many times a patient will ring the nurse during a 12-hour shift. So an expected value is basically an average. So an average value for X. So in fact, what you're finding when you're finding the expected value is the mean value of X. So that average as opposed to the median and the mode. All right? So the expected value of a probability distribution is the sum of all the x's times its corresponding probabilities. Okay, so I'm going to put xi and pi, and I'm going to go I equals 1 to n. So basically, as you go through the values, like x1, x2, x3, x4, you multiply each value of x with its probability. So you multiply the values from the first column with the values of the second column, add them up all the way to however many you have, and that will give you the expected value. Okay, so let's find the expected value here. So you're going to take the first x value, multiply with the first probability, 0 times 4.50. And then the next x value multiplied by its probability, 1 times a over 50. Next x value, 2 times 16 over 50. Next, 3 times 14 over 50. Next one, 4 times 6 over 50. And then the last one, 5 times 2 over 50. Alright, so let's see what we get. This is 0. Then we have 8 plus 32 plus 3 times 14 is 42 plus 24 plus 10 divided by 50. All right, let's add those up. So 40, 50, 92, and then 116. All right, let me check with the calculator, just in case. All right, so we have 8 plus 32 plus 42 plus 24 plus 10. 116 over 50, divide, we get 2.32. All right, so what this average means, this expected value, is that on average, in the long run, a patient, or maybe I should say, in the long run, a patient calls a nurse, rings the nurse, rings for the nurse, an average of 2.3 times in a 12-hour shift. All right, so that's the interpretation for this expected value. All right.